Alright, today we're going to be looking at our Unit 8 Assessment Review Factoring Polynomials. Now there is going to be a little more than just factoring polynomials on this test, so we'll touch on it a little bit in this review. So, first thing up is simplifying radical expressions. Some of you have done this really well, some of you still have not grasped this concept. So, I'm going to start with this first problem, square root of 150. Alright, so the square root of 150, I want to look over to the right side. And where this arrow is, those are going to be my possible factors. I want to see if any of my perfect squares factor into my 150. So, if I'm using a calculator or if I'm doing it by hand, I'm just going to go down the list. 150 divided by 1 equals 150. Of course, the square root of 1 will work. Now, I want to go to the next one. 150 divided by 4. 150 divided by 4 is going to give me 37.5. I don't want a decimal, so that means 4 doesn't work. Then I go 150 divided by 9. 150 divided by 9 gives me 16.66 repeating. So that won't work. So if you notice, I'm making my way down this side. 1 works. 4 did not. 9 did not. I go to my next term, 16. 150 divided by 16 equals 9.375. Again, that does not work. Next up, 150 divided by 25. 150 divided by 25 equals 6. So yes, 25 works. Now, for the sake of this problem, I'm going to stop there because I know that's as high as I can go. So my factors of 150 are going to be 25 times 6, and I cannot forget to put my square root symbol back over it. Now the square root of 25 I know is 5. So I can remove it from the radical as a 5 and circle it because I cannot simplify it anymore. The square root of 6, well 6 does not have 1, 4, 9, 16, etc. go into it, so I know I cannot simplify that anymore. Therefore, the square root of 6 is as simple as I can get. Now I just multiply those two terms together, and my simplified radical is 5 times the square root of 6. Now if we come over to the other side, we'll go ahead and erase this work here so we have room to work. If we come over to the other side, I have 5 times the square root of 600. Now I'm not simplifying the outside because it's out there because it's already simplified. I have to work on the inside of the radical. So 600, again I'm going to go down my list on the right side. I'm going to go down the list on the left side with the numbers underneath the radical. I know, for sake of time, that 600 factors out as 100 times 6. Again, don't forget your square root signs. The square root of 100, if we look right down here, is 10. So I can pull 10 away from the radical and circle it. And then square root of 6 is the same square root of 6 on the last problem. I cannot simplify it, so I circle that. Now, the difference between problem 2 and problem 1 is we still have a term that's on the outside, so it has to be included in my final answer. So my final answer is 5 times 10 times the square root of 6, which in this case is just 50 times the square root of 6. And you're complete. Now, I'm going to go ahead and show you 2 more problems. Work on them at your own speed. Pause the video if you have to for more time. Alright, going forward, factoring with the GCF. Alright, so we have to remember that GCF means greatest common factor. Greatest common factor. Not just common factor, but I want the greatest common factor. So in this case, my GCF, I have to identify how many terms there are, which in this case there are 1, 2, 3 terms. So 3, 9, and 24, the greatest common factor that those numbers share is 3. Now, I don't necessarily have to have a number in common with all of them. I might just have a variable in common with all of them. I could have just a number, just a variable, or both. So in this case, I know that 3 is the greatest common factor among the coefficients. Now, if I look at the variables, all of them have an x. So I know there's an x included. Now, I see that the first term has an x to the 6th, the second term has an x to the fourth, and the last term has an x to the third. I have to identify the lowest powered x as my greatest common factor. So in this case, x to the third, or x cubed, is going to be my greatest common factor. Now, if all it's asking for is your greatest common factor, then you'd be done here. So that's done with my greatest common factor. If it wants me to find the rest of the factors, or the other factor, I have to continue forward. So I'm going to pull down 3x cubed here, and now I'm going to search for my other factor. In order to find that, I simply divide every term by my GCF. Now, I'm going to do the expanded form of the first term just so you get an idea of exactly what we're doing. The expanded form of the first term is 3 times x to the sixth is simply x times x times x 6 times. 1, 2, 3, 4, 5, 6 x's. Divided by 3 times x times x times x, x cubed. Now, 3 divided by 3 reduces to 1, so I say it cancels. X divided by x reduces to 1, so it cancels. X divided by x again reduces to 1, so it cancels. And last time, x divided by x reduces to 1, so it cancels. So what does that leave me? It leaves me x times x times x, which can be written as x cubed. Now, if I wanted to do that piece by piece, or using my laws of exponents, all I have to remember is, if I'm dividing the like bases, my powers are subtracted. So, 3x to the sixth divided by 3x to the third. The 3's reduced to 1, so they're gone. And x to the sixth divided by x to the third is x to the sixth minus 3, which is x to the third. So I know that what's remaining out of my first term is x to the third. I continue that same process for the next two terms. I put my plus sign. 9 divided by 3 is 3. X to the fourth divided by x to the third. I take the 4, subtract the 3, and I get x to the first, so just x. And then my minus sign. 24 divided by 3 is 8. And x to the third divided by x to the third cancels completely. So I am complete. So I'm going to go ahead and flip to a couple more problems for you to work on your own. Again, feel free to pause the video to give yourself more time to work. Alright, now we're going to look at factoring polynomials and solving them. Now, I want to emphasize down here at the bottom, my way may not be the only way to factor. Just use the method that works best for you. As long as your problem is mathematically sound, you can get to the final answer. Alright, so let's look at problem number 1 right here. K squared plus 6k plus 8. Now, if we notice, there's no leading coefficient for k squared. Therefore, my leading coefficient is 1. Now, I don't have to write that 1 in there. I just put it there for a reminder. All right, so this is going to be handled how a equals 1, which means I can already draw my parentheses for my two factors and go ahead and fill in my variable, which in this case is going to be k to start with. K times k will give me k squared, so that's how I know k starts those. Now I'm going to go ahead and draw my x. I'm going to put my c value of 8 up top and my b value of 6 on the bottom. I need two numbers that multiply to 8 and add to 6, which in this case are going to be 4 and 2. Since that's a positive 4, I bring it down to plus 4. And since that's a positive 2, I'm going to make it plus 2. Now, if all it's wanting me to do is factor, then I'm done. But since this problem says factor and solve, I have to take it a step further. To solve, I have to take each factor, k plus 4 and k plus 2, and set both of them equal to 0. Now I'm simply solving a one-step equation. I subtract 4 from both sides here, and k equals -4. And I subtract 2 from both sides here, and k equals -2. So my possible solutions are k equals -4 and k equals -2. Now, looking at my next problem, we're going to call problem number 2. I have to notice that the leading coefficient of n squared is greater than 1. Therefore, my a is greater than 1. So, there's a couple ways I can go about solving this one. The way I'm going to approach it is slide, divide, bottoms up. So I'm going to start by sliding my 2 over to the 6th and multiplying. And then I have to rewrite my polynomial. So n squared minus n minus 12. 2 times 6 is 12. I'm going to keep the minus sign there in place. All right. Now I can treat it just like the problem we did before. So step 1 said slide, which I did. Step 2 says I have to factor this. So I'm going to go ahead and draw my parentheses in place. Fill in my variable, which both of them will start with an n. All right. I'm going to go ahead and erase this previous problem to give us a little more room. All right, now I have to draw my x. And when I fill in the c value and the b value, I have to remember I'm using my new c value and this b value. So my c value up top is -12. My c value, or my b value on the bottom, is -1. Remember, if there's no number in front of a variable, it's just 1. And in this case, it has a minus sign. I'm going to treat it as a -1. So, I need two numbers that multiply to a -12 and add to a -1. In this case, those numbers are going to be -4 and +3. So I fill them in exactly as they are, n minus 4 and n plus 3. Again, if it wants me to just factor it, now, am I done? No, because since I started with the slide, I have to remember the rest of my steps. Slide, factor, divide. I have to divide both of these numbers by the original a value that I slid over, which in this case was 2. And then I have to simplify it. So 4 over 2 reduces to 2. So I have n minus 2. And 3 over 2 stays 3 over 2. So n plus 3 over 2. Now my last step says if I have any denominators, then I can take the denominator and slide it to the front of the variable. So this 2 is going to slide up in front of the n. And my two factors are going to become n minus 2 times 2n plus 3. Now, I'm done factoring. But since it wants me to solve as well, I have to take both of these and set them equal to 0. n minus 2 equals 0, and 2n plus 3 equals 0. The first one, I add 2 to both sides, and I get n equals 2 as one possible solution. And the second one, I have to subtract 3 from both sides. But don't forget, I still have 2n equal -3. And so I also have to divide by 2. And n equals -3/2. Now I'm going to go ahead and flip to a couple of problems for you to try on your own. Now we're going to look at factoring some polynomials and solving again, but this time these polynomials are able to be solved using difference of squares. Now, how do I know they're able to be solved using difference of squares? Well, first off, I only see two terms, and I don't see a b value. So I have an a and I have a C, but I do not see a B value. Next way I know the square root of 64, I know the square root of G squared, and I know the square root of 16. So I can use difference of squares, and most importantly, I have to have a minus sign. If I do not have a minus sign there, I cannot use difference of squares. So let's go to work. I'm going to go ahead and open up my parentheses. And I'm going to take the square root of my first term. The square root of 64 is 8. And the square root of G squared is just G. Then I'm going to take the square root of my second term. The square root of 16 I know is 4. Now the most important part here is I have to make one factor plus and one factor minus. So one addition, one subtraction. And now I'm done factoring. Now, luckily for us, it also asks us to solve. So to solve, if you didn't guess it, you ought to know. I take each factor, 8g plus 4, and set it equal to 0, and 8g minus 4 equals 0. And I solve it. Subtract 4 from both sides. 8g equals negative 4. And divide by 8. So g equals negative 1/2. And then the opposite over here, plus 4. 8g equals a positive 4. Divide by 8 on both sides. And g equals a positive 1/2. Now, the more familiar way you're going to see that written is I'm going to have both factors come down, and g, or both solutions, I'm sorry, equals plus or minus 1/2. Now, the more you do these, the more you'll realize, hey, with difference of squares, I only have to set one factor equal to 0, because in the end, I'm just going to get a positive and a negative answer with the same number, which is why we put plus or minus 1/2. Now let's go over to this next one and try it. Do I know the square root of 25? Yes. Do I know the square root of n squared? Yes. Do I know the square root of 144? Yes. Do I only see an a and a c term? Yes. Do I see a minus sign? Yes. Then we can use difference of squares. So let's go. I'm going to open my parentheses. I'm going to take the square root of my first term, which is 5n. I'm going to take the square root of my second term, which is 12. And then, one addition sign, one subtraction sign. I am done factoring. To solve, I take each factor and set it equal to 0. So 5n plus 12 equals 0, and 5n minus 12 equals 0. Sorry to go off the screen a little bit. Alright, I lost connection for a second, so let's get back to it. I took the square root of 25n squared and got 5n and 5n. I took the square root of 144 and got 12 and 12. Made one a positive, one a negative. So we go 5n plus 12 equals 0 and 5n minus 12 equals 0. Alright, I subtract 12 from both sides. I have 5n equals negative 12. And then I divide by 5. And remember, I only have to solve one side because in the end, I'm just going to get a positive and a negative, and my number is 12 over 5. So this will lead to the positive number and the positive outcome on that one. So here are a couple more problems for you to solve. Again, pause if you need more time. And the last thing I have for you are some additional practice problems, something you might see on the assessment tomorrow, just a reminder. This first one, I want you to take a look. It's just adding and subtracting polynomials. So I would recommend that you add, which is what the plus sign represents, and I would recommend you subtract, which is why the minus sign is there as well. I figured if we learn this new symbol, then we might as well use it. And then the other ones are just multiplying binomials, distributing, and then evaluating functions. So, good luck. Hopefully this review helps you on the test.